All right, welcome to chapter 9. We spent chapter 8 working with quadratic equations and quadratic expressions. A quadratic is where you have an x squared or a variable squared. Now we're going to call them quadratic functions because they're not going to use a y, they're going to use the function notation, f of x. Remember that? So f of x is equal to ax squared plus bx plus c. Ax squared plus bx plus c is the form of the quadratic we had, and now it's going to equal the function output. They give you a little technicality, a can't be 0, because if a is 0, there's no x squared, because if this is 0, this whole term is 0, so it's no longer a quadratic. So a has to be something besides 0. All right, so this is called the standard form of a quadratic function. F of x is equal to ax squared plus bx plus c. Sometimes you'll see it written with y equals instead of f of x equals if they use the y instead of the function notation. So when we graph these, they're not going to be linear. They are going to be a shape called a parabola. That's how you pronounce that word, parabola. It's not called a parabola. It's called a parabola. A parabola is basically a U shape. The parabola is going to change its shape slightly based on the numbers that are in our quadratic function. Sometimes it'll get wide, sometimes it'll get narrow, sometimes it'll move up, down, left, right. Sometimes it'll flip and reflect. These are all things we'll talk about. Today we're just going to identify some specific points on the parabola and specific characteristics of the parabola. A parabola, this U shape, as you can see, this blue line, is perfectly symmetric. And that dotted red line down the middle will not be on the graph. That's mentally there. It's imaginarily there. And that is the symmetry line that reflects it. It's called the axis of symmetry. Because that's a vertical line, we will write an equation for that line. That will be an x line, x equals line. We'll talk later about how you find it. The point where the parabola changes its direction from going downward to upward or upward to downward, right on the axis of symmetry, is called the vertex of the parabola. Okay? So we have an axis of symmetry, the reflection line. We have a vertex. We have a couple of points on the graph hidden by this text box. This graph does cross the y-axis. We'll still talk about y-intercepts. It's right about there. We'll still talk about y-intercepts. Y-intercepts are important parts of any graph. Notice this also has some x-intercepts. They're not whole numbers in this case. We'll discuss what they are. But x-intercepts are going to be important. And then this point at the vertex is also going to be important. These are all characteristics we're going to talk about today. Specifically, that vertex point is going to be either a minimum or a maximum value. Here's two examples. It's a minimum if it's the bottom of the graph. If the graph opens upward, you have a bottom number. You have a minimum value. If the graph is flipped or reflected and opens downward, you'll have a top point, a maximum value. And that maximum value or minimum value are at the vertex. And the thing that makes that graph flip over is the a value. If the a is greater than 0, the parabola will open upward and have a minimum value. If the a is less than 0, the parabola opens downward, see it pointing downward, and has a maximum value. All right, so what we're going to do today is look at some graphs, identify some of these points, some of these characteristics, and get comfortable with some of the terminology. So I have 4 examples here for you. These are the things that I'm going to want you to be able to identify. First of all, does this parabola open upward or downward? Well, hopefully, obviously, you can say that this opens upward. And because it opens upward, it has a bottom number. So that bottom number is the minimum. It has a smallest value. It has no largest value because these arrows mean it's going to extend infinitely upward. So there's no largest value, but there's a smallest minimum. And that minimum is a y value. So if this is the origin, -1, -2, -3, -4, that minimum is a value of y is equal to negative 4. There's a y-intercept. It crosses the y-axis. Ironically, this time it crosses the y-axis right at that minimum value. So the y-intercept is also negative 4. This makes it a special parabola. There are some x-intercepts. They're right here and right here. Well, because this minimum, this point is on the y-axis, the x-intercepts are going to be opposites of each other. If this is the origin, this is positive 2, this is negative 2. So the x-intercepts are at negative 2 and positive 2. The axis of symmetry, that reflection line, goes right down the middle, right on that y-axis. Well, on the y-axis, the x value is 0. And the vertex is a coordinate. Well, the vertex right there is a coordinate. X is 0 and y is negative 4. Notice that the vertex is a combination of the axis of symmetry, x value, and the minimum or maximum, y value. Those are all, for now, the characteristics of a graph I want you to be able to identify. Just going to do it visually for now. Let's take a look at another one. Just visually looking at this, you can obviously tell this graph is opening upward. And because it opens upward, it has a lowest point. Therefore, it has a minimum. And that minimum y value, well, it comes down to here. So that minimum y value is 0. Has a y-intercept right there. That y-intercept is 1. This only has one x-intercept. Doesn't have 2, because the minimum of that parabola is right on the x-axis. So the x-intercept here is negative 1. There's a single x-intercept. The axis of symmetry, right down through the middle, is also x equals negative 1. And the vertex point, that point I keep identifying right there at the bottom of that parabola, is a combination of the axis of symmetry, x value, and the minimum or maximum, y value, as a coordinate. So it's negative 1, comma, 0. That's the coordinate of this spot right here. All right, couple more. Quick visual. This parabola definitely is opening, pointing downward. That means I don't have a bottom to my parabola, I have a top. And that top gives me a maximum value of y is equal to 1, 2, 3. The y-intercept, right there. The y-intercept is negative 1. Notice the y-intercept is less than the maximum because it's going down from the center. X-intercepts. Well, I have 2 x-intercepts, but this time my x-intercepts are not whole numbers. For now, I'm going to estimate them. We're going to be able to get them exactly. You actually know how to do it already. You just don't know that that's what it tells you. But the x-intercepts, I'm going to say this is about 0.25. And that this one is about 3.75. Estimating is not going to be what we're going to do in general, but until you know how to find them exactly, we'll estimate with this picture. The axis of symmetry, that center line that reflects the graph, the parabola, is x equals 2. So therefore the vertex, this coordinate right here, is the combination of the x value of axis of symmetry, 2, and the y value for, in this case, a maximum, 3. All right? And last but not least, quick visual. This parabola opens upward, which means it has a bottom, a minimum value of y is equal to 1, 2, 3. Has a y-intercept right there. Y-intercept is above the minimum. So the y-intercept is 4. X-intercepts. Here's my x-axis. Doesn't intercept the x-axis, and it never will, because it's never getting lower than here. It's never going to get down to there. So this is another special parabola. There are none. There are no x-intercepts. These are going to be fun when you figure out how to find that. Axis of symmetry goes right down through the center here, the reflecting line. X is equal to 1. And therefore the vertex, the coordinate right here, is 1, 3, the combination of the x and the y. 1, 3. All right, that's the basics, identifying the different parts of a parabola and a quadratic functions graph. There's a second video coming too. Have fun today.